Variance of a sample in a population. So far, we have used the term variation as a general description of the amount that values vary among themselves. The terms dispersion and spread are sometimes used instead of variation. The term variance has a specific meaning. The variance of a set of values is a measure of variation equal to the square of the standard deviation. So for the sample variance, what you're doing is you're squaring the sample standard deviation, which is the square of the standard deviation, or the sample standard deviation. For the population variance, you're squaring the population standard deviation. Now the notation summary, remember that lowercase s is the sample standard deviation, s squared is the sample variance. Sigma is the population standard deviation. Sigma squared is the population variance. Now, what are the important properties of variance? Well, the units of variance are the squares of the units of the original data values because you're squaring the sample standard deviation or population standard deviation. The value of the variance can increase dramatically with the inclusion of outliers, so therefore the variance is not resistant. The value of the variance is never negative. It is 0 only when all of the data values are the same number. And the sample variance, s squared, is an unbiased estimator of the population variance, sigma squared. Now, the variance is a statistic used in some statistical methods, but for our present purposes, the variance has this serious disadvantage of using units that are different than the units of the original data set. This makes it difficult to understand variance as it relates to the original data set. Because of this property, it is better to focus on the standard deviation when trying to develop an understanding of variation. Now also, why divide by n minus 1? Well, there are only n minus 1 values that can be assigned without constraint. With a given mean, we can use any numbers for the first n minus 1 values, but the last value will then be automatically determined. Now, with division by n minus 1, the sample variances tend to center around the value of the population variance. So with division by n, or the lowercase n, sample variance tend to underestimate the value of the population variance.